Specifically today, we're going to work on multiplying binomials. So we're going to take a binomial times a binomial today. So we're talking about a binomial. We're talking about two terms. Excuse me. So yesterday it was all about one term times one term, a monomial times a monomial times a binomial, where we use the distributive property. Now today we're going to take a binomial times a binomial. So hopefully by the end of the hour we'll be able to tackle any binomial times binomials. And there's really a nice little pattern that kind of helps and happens here. You are really just using the distributive property when you're doing these. I've got a bunch of arrows facing different directions here. But my first binomial is a plus b. My second binomial is c plus d. And it follows a pattern when we do this. What we're going to do when we do these. So the first part, really, we're distributing this a. And we're going to take a times whatever c is. Again, it's more likely to be a number or a variable, whatever it is. But the first step is to take your a times your c and then take the a times the b. So essentially, you're taking that a value and you're distributing that a value from the first polynomial and distributing it into the second one by multiplying it by each term of the second polynomial. Then what you're going to do is you're going to take the second term of the first polynomial, b, and you're going to take it b times c. So you're essentially going to distribute that second one of the first polynomial into each of them in the second one. So we've got b times c plus b times d. So we've got this whole string of things kind of going along. And really all this is the distributive property. You're distributing each term from the first polynomial and multiplying it by each term of the second polynomial. We kind of have another way to look at it. What we say is you take the first terms of each binomial and multiply them together. So the first terms of each of the binomials are a and c. So that's a times c. You take the outside terms of each of the polynomials. So our outside terms are a and d. So you just take a times d. You take the inside terms. So the inside terms are the ones that are the innermost of each of the polynomials, or by each other. B times c. And then you do the last terms of the polynomial. Then you're multiplying all those together, so you get b times d. So we've got first terms, outside terms, inside terms, and last terms. And this is always used anytime we're talking about multiplying two binomials together. Well, we have kind of something we use in mathematics. You'll hear us say a lot. You'll hear a lot over the next several years. You'll hear us say FOIL it. The F in FOIL stands for first. O stands for outside. I is for inside. And L is for last. So you'll hear me say FOIL it. FOIL it. First, outside, inside, last. And that's just a description of how we go about multiplying two binomials together. First term times first term. Outside term times outside term. Inside term times inside term. And last term times last term. First, outside, inside, last is how we go about multiplying polynomials. And so there's the process of how we go about multiplying two polynomials. Now let's take a look at several examples of this. And I'll flip back to this slide here at the end. if you didn't get a chance to get it all copied down. So let's say we have something like x plus 3 times x plus 4. Okay, so those are our two binomials. Okay, we filled them in, no more A's, B's, C's, and D's. Okay. So the property that we just talked about says that we take the first times the first. So our first term in each of them is x and x. So I'm going to take x times x. Plus. So this plus sign comes from, just because there's a plus sign here and here. If I multiply these together, it's going to be a plus. So it's plus outside x times 4. So those are our outside terms. So if we drew the arrows, so we have first, outside. Now the 3 times x is our inside. Our inside is right here, 3 times x. And then our last term is 3 times 4. So we've got first x times x, outside x times 4, inside 3 times x, and last 3 times 4. Now we're going to obviously combine those and put those together. So when we multiply it, x times x is x squared. X times 4 is 4x. 3 times x is 3x, and 3 times 4 is 12. So now we have something that we're familiar with. Now, I didn't underline the x squared. I could have put 2 lines underneath the x squared. I didn't do that. I mean, we could put 2 lines underneath there because it has a degree of 2. So I'll go ahead and put those 2 lines in there. I forgot to do it earlier. So that's got 2 lines. 1 line, and none line, no lines. That means we can combine those middle 2 terms and end up with a final result of x squared plus 7x plus 12. And that's our final result of multiplying together these 2 binomials. X plus 3 times x plus 4. Now, will the middle term always disappear? Not always. If the 2 terms in the first binomial are the same degree as the first 2 terms in this binomial, yeah, the middle will go away. They'll combine, but it's not always the case. So you do need to write it out and assume that it's not going to go away. Okay. Let's go with 2x minus 4 times 3x plus 8. Again, we've got these 2 binomials. We're going to go ahead and combine them using the distributive property. So first means we're going to take 2x times 3x. What do I multiply next? What are my outsides? What are my outside terms? So we took care of the first. What's the outside? What are their values? What's the outside term in our first one? 2x or 4? What's on the outside? 2x. Okay, so we're going to go 2x times what? 8. So it's 2x outside, it's 2x times 8. Inside. Our inside terms are negative 4 and 3x. So this is going to be minus 4 times 3x because there's a negative in front of the 4. And then the last one, negative 4 times 8. First terms, outside, inside, last. 2x times 3x, 6x squared. 2x plus 8x. 2 times 8 is 16, so that's 16x. 4 times negative 3 is negative 12, so that's negative 12x. 4 times 8 is 32, so minus 32. Second degree, first degree, and none. So we can combine the two first degree ones. 16 minus 12 is 4. So that's plus 4x minus 32. And there's your solution. Okay. First, outside, inside, last. And it's a distributive property. Want to try one on your own? We really don't need to write down that second step. We can just, kind of hard to see. So 2y minus 10 times 3y plus 7. All right, we'll do this one. We've got a few more we're going to do, so we'll do this one together. So now let's kind of eliminate one of the steps. We really don't kind of go to this step and kind of just do it, right? So first, oops, that was bad. So the first, 2y times 3y. 2 times 3 is 6, so that's 6y squared. That's our first. Outside is 2y times 7, so plus 14y. Inside, negative 10 times 3y, negative 30y. Last, negative 10 times 7, negative 70. Second degree, first degree, none. So 6y squared. 14 minus 30. Negative 16, I believe. Negative 16y minus 70. They're done. Again, we're foiling it. First term, outside term, inside term, and last term. Go ahead and try that one. Try that one on your own. 10x squared plus 2y times 4x plus 6y. Do they have any that look exactly the same? So if they don't look the same, then you can't combine them. So I don't think you can combine anything on this one.
So I can just multiply the ones that have variables and that have the same variable, right?
What's that?
I can just multiply the ones that have the same variable.
You can multiply anything by anything. Doesn't matter. But yes, just add the exponent. So if we multiply the first one, what's 10x squared times 4x? What's 10 times 4?
40.
40. What's x squared times x? X squared, cubed, cubed. Remember, there's understood to be a 1 there. So there's our first term. Now we do the outside term. So we go 10x squared times 6y. So we multiply the numbers together. 10 times 6 is 60. Do we have anything to multiply by x by? There's nothing to multiply the x by, so we're just going to put x squared y. 6y doesn't have any x's to it, so we're just going to bring the x squared and the y along. Inside, 2 times 4 is 8. Just to keep it in alphabetical order, I'm going to put xy there. We've got an x there, we've got a y there. We just combine them for 8xy. And then the last is 2y times 6y. 2 times 6 is 12. Y times y is y squared. Do any of these look exactly the same as far as their variables? They don't. That's your answer. You can't combine these middle terms because it's x squared y and this is just x. Remember from the last part of this unit, in order to combine them, their variables and exponents have to be exactly the same, and they are not. Next one. Let's go 2x plus 4 times 3x minus 7. Go ahead and simplify that expression. Okay, so our first terms would be 2x times 3x, just showing you another way that maybe it'll help you to do it. 2x times 3x, 6x squared. So that's our first term. Outside term is 2x and negative 7. 2x times negative 7 is negative 14x. Inside is 4 times 3x, which is 12x. And last is 4 times negative 7, which is negative 28. Now you can combine those two middle together for an end result of 6x squared minus 2x minus 28. Any questions on that one? Starting to make sense a little bit? Let's try the next one. That's fine.
My brain doesn't work. It's not.
No, that's fine. So 3xy plus 7 times negative 2xy minus 4. All right, I'm going to show you a little bit of a different way to do it again. Just showing you something else that maybe you can do. Some people like this method for binomials, some don't. We can also use what we call a box method, and you'll learn more about this tomorrow when we're talking about little bigger ones. But this is called the box method for doing these. When we do it using the box method, each of these boxes is going to get a piece of the monomial. So the 3xy and 7, they get their own piece over there. And the negative 2xy and 4 get their spots there. Now what you do to fill in the box is you go column times row. So I take 3xy times negative 2xy. And if you notice, that's just the first terms. So if I do that, I get negative 6x squared y squared. To do the next one, I'm going to take 3x squared times 4, which is just our outside. So 3 times 4 is 12, so that becomes 12xy. So that's my outside terms. Now my inside terms are 7 and negative 2xy. So 7 times negative 2xy is negative 14xy. And last, 7 times 4 is 28. It's just a different way to organize it. But You still have to combine like terms. So those are my two like terms. So I get an answer of negative 6x squared y squared minus 2xy plus 28. It's just another way to organize kind of the data. It's kind of in a square or a box method. We'll use that box method a lot more tomorrow when we're multiplying trinomials times trinomials. It's a lot easier to use that box method in this case. Some people like to use it with binomials, some people don't. It's just, again, another method to this. Okay. 2 more. Well, 4 more, but 1 more of these, and then we'll do a little bit of a recap, and then we'll should be able to call it good for today. So 7x squared minus 3 times negative 2x minus 4. All right, here we go. I'll use the FOIL method for this one. So first, 7x squared times negative 2x. 7 times negative 2 is negative 14. X squared times x is cubed. So negative 14x cubed. Outside, 7x squared times 4, negative 4, so that's negative 28. X squared. Inside, negative 3 times negative 2 is 6. Just bring the x along. And last, negative 3 times negative 4 is positive 12. We've got 3, 2, 1, and none. Nothing you can do with it. Circle it and move on. So multiplying binomials. You're multiplying binomials, remember the FOIL method. First terms from each. Outside terms from each. Inside terms from each. And last terms from each, and multiply them together. Make sure you combine any like terms that you can combine. I'm not going to make you do these. We did these yesterday. Just a review from yesterday. I think we're good to go. I don't think we need to do any more. I think we're in a pretty good spot right now. 10:19, so this gives you about 15 minutes. You should be good. If you open up your assignment,